All right, you guys, so this is 7.1.6, which is the section on the unit circle. This is probably one of the most important sections of the chapter, in my opinion. So in order to get this resource page, it's just on the website on Friday. It just says print unit circle. So what we're going to do is we're going to go ahead and start putting all of the degrees in on the unit circle. So we'll start with that. And then we'll go with the radians after that. So I'm going to actually do I'm going to kind of do this in colors. So I'm going to start with the main quadrant. So we have 0 degrees, 90 degrees, 180 degrees, 270 degrees, and 360 degrees. All right, so from there, we're going to do the 45-degree angles, and I'm going to switch colors again. And I'm also going to actually add in lines. All right, so this would be 45 degrees, and then plus 45 would be 90, plus another 45 would be 135, plus 45 would be 180, plus 45 would be 225, plus 45 is 270, plus 45 is 315, and plus 45 would be 360. All right, from there, we're going to go to our every 30-degree angles. So I'm going to put those in. And they have extra dots here that we're not going to use. We're just going to do the 30, 60, 90s, 45, 45, 90s. So this would be 30 degrees, and then next would be 60. The next would be 90. Next would be 120 degrees. Next would be 150. After that would be 180. And then we have 210. And then we have 240, 270, 300, and 330. So remember, you could always pause if I'm going too fast. All right, so the next thing that we're going to do is radians. So I have a couple of tricks that will hopefully make this a little bit easier. So you definitely want to make sure you are watching this, because a lot of people think that they just need to memorize it, and you definitely don't. So we're going to start with the main quadrants, which should be pretty easy. Because we just went over this in our last section. So we have 0 pi. I'm going to go back to my skinnier pen. 0 pi, and then at the top we would have pi over 2. This would be pi. 270 would be 3 pi over 2. And 360 would be 2 pi. All right, next we're going to go ahead and do the 45-degree angles. So we can absolutely convert them. So that's one way to do it. So for example, I could say 45 times pi over 180, and then we would get 45 pi over 180, which ends up being pi over 4. All right, so 45 degrees is the same thing as pi over 4, but what happens is every single 45 degrees, you're just adding pi over 4. So for example, 45 degrees would be pi over 4, and then the next, which would be 90, would be 2 pi over 4. So 135 would be 3 pi over 4, and then 180 would be 4 pi over 4, which reduces to pi. 225 would be 5 pi over 4. 270 would be 6 pi over 4, which reduces to 3 pi over 2. And 315 would be 7 pi over 4. So a lot of my students just kind of memorize the fact that it is just the 45-degree angles are every time it's over 4, and then it goes up 1 pi, 3 pi, 5 pi, 7 pi. All right. Next is the 30 degrees. So for every 30 degrees, well, again, we can start by, well, what is 30 degrees in radians again? So 30 times pi over 180 is equal to 30 pi over 180, which reduces to pi over 6. So what that tells us is every 30 degrees is pi over 6. So for example, 30 degrees is pi over 6, so then 60 would be 2 pi over 6, but we're going to reduce that to pi over 3. 90 would be 3 pi over 6, but that reduces to pi over 2. Next 30 would be 4 pi over 6, but that reduces to 2 pi over 3. Next would be 5 pi over 6. The next 30 degrees, which would be 180, would be 6 pi over 6. 210 would be 7 pi over 6. 240 would be 8 pi over 6, which reduces to 4 pi over 3. 270 would be 9 pi over 6. 300 would be 10 pi over 6, which reduces to 5 pi over 3. And then 330 would be 11 pi over 6. And then we end up at 360, which is 12 pi over 6, which is just 2 pi. All right, so now we have on our unit circle all of the degrees and all of the radians for our main quadrants. All right, so what we are going to do next is find the ordered pairs of each of the points on the unit circle that we have. So we'll start with the main quadrants because those should be the easiest for us. All right, so for the first one, we know that the radius is 1, so this point, and it's going to get a little bit messy with all of our writing, but the first point would be 1, 0. The next point would be 0, 1. 180 would be -1, 0. 270 would be 0, -1. And then again, we know that 360 would be 1, 0 once again. All right, so now we are going to do the 30, 45, 60, and so on. So remember, you should remember or have known from one of the previous sections that when we are talking about ordered pairs on the unit circle, the ordered pairs are cosine of that angle, sine of that angle. So that means each of these ordered pairs, so for example, when I'm starting with 30, I need to find the cosine of the 30, which will be the x value of the point, because that's the horizontal distance, and then I need to find the sine of 30, which will give me the y value of that point, or the vertical distance. So we'll do it for the first couple by doing our special triangles. So I'm going to kind of do that on the side. So I'm going to draw, let's say I have a 30, 60, 90 triangle, because I have 30 degrees, this is 90, this is 60. So opposite of 30 is 1, 60 √3, 90 is 2. All right, so I want to find the cosine and then the sine, because the cosine is going to be the x value. Well, cosine is adjacent over hypotenuse, so this would be √3 over 2. And then the y value would be the sine of 30, which is 1 over 2. All right, so that's that point. Now we're going to do that same thing, but for the 45-degree triangle. And some of you may already know this, but I'm just doing it just in case. So we have 45. My line went away. 45, 90, 45. So we know that's 1. That's should be √2. So 1, 1, and then we have √2. Trying to erase that. Okay, so cosine would be adjacent over hypotenuse, which is 1 over √2, and sine would be also the same, 1 over √2. But we know we can't leave it like that because you can't have a radical in the denominator, so you have to rationalize it or get rid of it. So this would become, this point is going to become √2 over 2, √2 over 2. All right, keep in mind we are not going to do this for every degree, because that would be absolutely crazy. But we are going to do this, and then I think we will remember the pattern from when we did the Ferris wheels. So next would be 60. So again, I'm going to draw my special right triangle. So I have 60 degrees. So 60, 30, 90. Opposite of 60 is root 3. Opposite of 30 is 1. Opposite of 90 is 2. So this time we're finding, again, the x value is the cosine, which would be 1/2. The y value is the sine. So it's actually the exact opposite of what we got for 30, which makes sense. So for 60, we should have, if I can fit this somewhere, it would be 1/2 comma root 3 over 2. Now that we got to this point, we're really just going to reflect all of this across. So for 120, I know it's going to be 1/2 comma root 3 over 2, but because we're in quadrant 2, that 1/2 has to be negative. So it's going to be negative 1/2 comma root 3 over 2. I'm going to go ahead and do the 150 while I'm on this color. So it's going to just be the same as 30, but I have a negative root 3 over 2 and a positive 1/2. All right, so now I'm going to do the 135, which will be the same as 45, except it will be a negative x value, so negative root 2 over 2, comma, root 2 over 2. All right, moving downwards, I'll do 225. So it's going to still be root 2 over 2, root 2 over 2. However, x and y are both negative. So it'll be negative root 2 over 2, comma, negative root 2 over 2. All right, and then we go to the other one. So 210 is going to be the same as 30 and the same as 150 as far as the values, but both are negative because x and y are negative in this quadrant. And same for 240. So it will be negative 1/2, comma, negative root 3 over 2. All right, and then moving along to 300, it's going to be the same as 240, except the x value is positive, but the y value is negative. And then we know for 330, it's just the opposite. So it's going to be root 3 over 2, comma, negative 1/2. And then I will just go back and finish 7 pi over 4 and 315, which will be root 2 over 2, comma, negative root 2 over 2. All right, it's a lot. So a couple of really important things that you should notice. Obviously, every x value is the cosine of that angle, and every y value is the sine of that angle. So you definitely want to make sure that you have that. So x comma y. The other thing is noticing like kind of what's positive and what's negative. So we have this thing, and I'm sure some of you may have heard of it. We call it all students take calculus. So what that means is in the first quadrant, all trig identities are positive. So in other words, sine, cosine, and tangent are positive. In the second quadrant, only sine is positive, and that makes sense because cosine is the x value, and the x value has to be negative. In quadrant 3, only tangent is positive. And I'm going to kind of write up here, we should have written this, but tangent is y over x, or you can think of it as sine over cosine, because it's opposite over adjacent. So tan is y over x. So tangent is positive there because it is a negative over a negative. And then in quadrant 4, only cosine is positive because the y value is negative. So if the y value is negative, tangent will automatically be negative. So I will share a nice clean copy of this because I know this is quite messy. But this is definitely an important topic, and this is how you generate the unit circle.